Hey all, hope everybody are doing good and welcome back to Homeschool. Today I am with a model question paper that was released by SSLC Karnataka board for the year 2022 board examination. This year's model question paper is quite different compared to the previous year's papers because this year all the questions are divided into three categories. You have part A questions, part B and part C. Part A is completely on physics. So you have all the physics questions in part A, and part B is related to chemistry and part C is related to biology questions. Okay, so this is how the entire question paper is divided into three parts. Coming to part A, the physics questions had covered 28 marks, and chemistry you have for 25 marks and biology questions are there for 27 marks. So altogether 80 marks paper that you have to write within 3 hours. Okay, so that is the overall picture of your model question paper. So in this video, I am going to cover all the questions that is there in part A, that is physics part. And in my next video, I mean tomorrow, I will upload a video on all the questions that I covered under chemistry. And third video is on biology questions. Okay, so this is how this model paper I have divided into three categories and I made three beautiful videos. Okay, so let's quickly go for the different questions that you have in physics. And trust me, I'll be explaining you the total concept that is there around the question. Okay, not just the answer. I'll talk about the entire concept that's rotating around the question. So watch the video till the end. Definitely, this is like a best revision for you in the form of question and answers. So let's quickly go to the first main. See, the first main under physics part is a multiple choice question. So first main, you have two multiple choice questions, each carrying 1 mark. Okay, so under this, the very first question is something like this, which is displayed on the board also. The diameter of the reflecting surface of spherical mirror is optical center, center of curvature, aperture and principal axis. Definitely the diameter of reflecting surface of spherical mirror is aperture. So option C, that is aperture, right? So if you take, this is concave mirror I took, and this length, the reflecting surface, this much, this, let me take it as mn. So this surface we will call it as aperture. That's what they asked you, right? So what is center of curvature? Center of curvature, if you imagine that this as a sphere, so center of that sphere which we can represent as C, that is called as center of curvature, right? And what is optical center? See, optical center you will observe in lenses, spherical lenses, right? And principal axis is, if you draw a line, which is passing through center of curvature and pole, center of aperture is pole. So when you draw a line passing through center of curvature and pole, then you call that line as principal axis. But here what they asked you, the diameter of the reflecting surface. So this one they are asking you, right? Reflecting surface is what we call it as aperture, right? So option C, aperture is correct answer. Coming to second question, it's a very simple and direct problem. An electric motor takes 5 ampere from a 220 volt electric source. The power of motor is, so what is the formula for power? Power is equal to volt into current, that is I. So voltage is given, guys, how much? It is 220 volts. And I, that is current, is given, that is 5 amperes. So if you calculate, you get your answer 1100 watt, right? So this is your answer. So where is this answer placed? Definitely as a first option. Okay, see, whenever you write answers for multiple choice question, you mention, see whether your correct answer is A, B, C, that you have to mention and write a complete answer. Okay, don't just leave your answer till here. You have to complete the answer by writing the correct option. Okay, so don't just leave your answer as C. You write what is that C? It is aperture. Okay, so don't just write your answer as A. What is that A? It is 1100 watt. So this is how you have to write answers for multiple choice questions. Okay, so that is all about your first main. Coming to second main. Under physics part, second main, you have 3 1-mark questions. So 3 into 1 is equal to 3. The first question is very simple. That is our third question. If the focal length of a spherical mirror is 15 centimeter, find the radius of curvature. See what they have given? Focal length is given, that is 15 centimeter. They are asking you radius of curvature. So we know the relationship, right, between radius of curvature and focal length, that is R is equal to 2F, right? So what is R here? 2 into F is how much? 15 centimeter. So radius of curvature is equal to 30 centimeter is your answer. So this is how first you have to write the formula. For writing a formula, you will have half a mark, and then for showing your answer with unit, half a mark. So altogether it is 1 mark question. Clear? Fine. Coming to fourth question. Very simple. Mention any 2 disadvantages of fossil fuels. See, we all know it's a general question, isn't it, from sources of energy? Fossil fuels are non-renewable sources of energy, right? Non-renewable sources of energy. So what do you mean by non-renewable source of energy? See, one fine day, these fossil fuels will get extinct. They get over. We cannot use it again and again, right? And to form fossil fuel, it takes millions years of time. So such a source we will call it as non-renewable source of energy, right? So fossil fuel is non-renewable, right? It takes many years to form, million years to form, and also one fine day when you use too much, it will get over, it will get extinct. So that's what we mean by this point. And coming to, they asked 2 points, right? So this is 1 point, and second point is they cause pollution. They cause pollution, right? So petrol and diesel, you get it from fossil fuels. So petrol and diesel, they give lots of smoke into the atmosphere. So that smoke contain many dangerous gases that can cause air pollution, right? So these are the 2 points you can mention there. Coming to fifth one, very simple question from the chapter electricity. What is an electric circuit? So what is an electric circuit? It is a closed and continuous path. Closed and continuous path for flow of electrons. For flow of electrons. See, along with me, you can note down these answers in a book, because questions from model papers are very important, guys. Something like this can be asked in the final examination also. You take a screenshot, or you can better write down all these answers in the notebook. Clear? So these are your second main answers, 1 mark questions. Now let's go for third main, that is 2 mark questions. See, coming to sixth question of third main, which is of 2 mark. As I already told you, you have 3 2 mark question. Okay, 3 into 2 is equal to 6 altogether. So sixth question is this. How does overloading and short circuit occur in an electric circuit? Explain. What is the function of a fuse during this situation? See, you have to write the definition of short circuiting and overloading, that much. So what do you mean by short circuiting? See, I have written the answer in a very short form, I mean in a very simple form. You can copy down this answer in your book, okay, so that it's very easy to remember. You will observe short circuiting when live wire comes in contact with neutral wire. Okay, so whenever these two wires touch with each other, short circuiting occurs. Okay, so this results in zero resistance. When these two wires touch with each other, resistance will become zero, so that lots of current is flown through the wire, right? So this results in zero resistance, causing flow of large current, causing fire. So this is the definition you can write for short circuiting. Coming to overloading, occurs when many appliances switched on at the same time and they draw large current. This causes overloading of wire which damage appliances. Okay, when too many electrical appliances are connected at the same time, and when all of a sudden they draw large amount of current, this damages the appliances and this damages the wire also. So that is what we mean by overloading. Okay, and they asked one more question here. What is the function of a fuse during this situation? It helps in breaking circuit. Okay, so that way it helps during the time of short circuiting and overloading. Okay, so it actually helps us from electric shocks that causes due to short circuiting and overloading. Okay, so how does it help? It helps in breaking circuit. Okay, so this must be the answer for the 6th question. Coming to 7th question. 7th question is very simple, guys. So they asked you to draw a diagram of biogas plant, which you have in sources of energy chapter. So very simple, you can open the textbook and see how the diagram looks like and practice the diagram. Now I'm not showing it on a board. And directly I'll go for 8th question. So 8th question is a very simple problem from the chapter electricity. Read carefully and try to solve yourself. Pause the video, try to solve, and then match your answer with my answer that I am doing it in a video. Okay. An electric lamp whose resistance is 40 ohms. So you have electric lamp whose resistance is 40 ohms. And conductor of 8 ohm resistance. You also have some conductor with 8 ohm resistance. Fine. They are connected in series to a 12 volt battery in an electric circuit. So first you have to draw a diagram, guys. So, both are connected in a series to a 12 volt battery, right? So battery voltage is 12 volts. And this is 40 ohm, this is 8 ohm. Very fine. What they asked you is calculate the total resistance. So you have to calculate total resistance is how much, and also current is how much, I is how much. First you find the total resistance. See, what is the resistance in series? You just add both of them, right? R1 plus R2 is the formula. Say, suppose if this is R1 and this is R2. So what you will do? You just do 40 plus 8, which is equal to 48 ohms is the total resistance, right? So this is our total resistance. So for one question, we have got the answer. Total resistance is 48 ohms. And they also asked you to calculate current, right? So according to Ohm's law, we have a formula V is equal to IR. So I is equal to V by R. So what is V here? Volt, that is 12. 12 divided by resistance is 48, right? So 12 ones are 12 fours are. So 1 by 4 amperes is the current. So 1 by 4 in the sense what? 0.25 amperes is equal to the current, right? So your total resistance is 48 ohms and your current is 0.25 amperes. So very simple basic problem. So this is how you have to calculate. So that's all about your third main. Okay, and now let's go for the fourth main, that is 3-mark questions. So under 3-mark question, you have 3 questions. Okay, so they asked you to draw the ray diagrams from the chapter light. So ray diagrams are very, very important. Compulsorily 1 question will come for 3 marks. So you have to practice all ray diagrams of concave mirror, concave lens and convex lens. Okay, so let's see what is that question here. See the 9th question here. Draw the ray diagram of image formed when object is kept beyond 2f1 of convex lens. Okay, so object is kept beyond 2f1 of convex lens. Okay, with the help of diagram, mention the position and nature of image formed. Clear? So what is a convex lens? How do you put a convex lens? This is our convex lens. So here this is optic center O and this is our principal axis, and here you have F1 and 2F1, right? And this is our F2 and 2F2, right? Fine. And where is the object kept? Beyond 2f1. So here is the object kept. So if you draw a line, incident ray parallel to principal axis, then it will pass through f2, isn't it? Arrow marks are very important, guys. So refracted, this is a refracted ray passing through f2. So another ray, how do you take? You will take it ray which is passing through optic center. So there is no refraction here, so it will pass straight, isn't it? So arrow marks are very, very important here, right? So now where are these 2 rays are meeting? Somewhere here between f2 and 2f2, right? So where is image position? Image position, you have to write this way. Image position is between f2 and 2f2. So if you keep an object beyond 2f1, you get your image between f2 and 2f2. And what type of image it is? Nature. Nature of image is what? It is a real image, real and inverted, right? Real and inverted image you will get. So inverted, isn't it? So this is what you have to mention, guys. So for this you have got 3 marks. So very simple. Only thing is you have to practice the ray diagrams properly. Definitely 1 question will come from the ray diagram concept. Fine. And if you want how to do these ray diagrams, I have a beautiful video. I'll provide the playlist link in the description. You can go and check it out. So complete concept of light chapter is covered in a very detailed way, right? Don't forget to go to the playlist and check with the concepts. Fine. And there is a or question here. Okay, so or, so you have another choice. Even this is a ray diagram itself. They are asking you to draw the ray diagram when ray diagram when of image formed, the object is kept beyond C of concave mirror. Okay, so how do you do a concave mirror? So this is our concave mirror, isn't it? This is a center of concave mirror, which is a pole, and a line passing through a pole, center of curvature, and pole is principal axis. Okay, so here you have focal length, that is f, right? Fine. So what did they ask you? If an object is kept beyond C. Okay, so beyond C in the sense, so here an object is kept. So if you draw an incident ray parallel to principal axis, it will pass through, you know, focal length, right? The reflected ray will pass through focal length. And if you draw a line passing through center of curvature, you know, say the reflected ray is also, is same path but in a opposite direction, right? So this is how we will have to show, right? And now where are these two lines meeting? These two lines are meeting in between C and F. So where is the image formed? So image position is between C and F. And what type of image? Even here it is real and inverted image, right? So either this or this you can neatly draw and show them, and don't forget to mention these points, they carry mark. Clear? And showing arrow mark is also as important as you draw a ray diagram. Clear? So that is all about 9th question, guys. And coming to 10th question, very simple question from the chapter electricity. What is electric potential difference? What is the SI unit of potential difference? Name the device used to measure the potential difference. So you have to write the definition of electric potential difference. The electric potential difference is at a point, which is defined as work done to bring positive charge, unit positive charge from infinity to that point, is called electric potential difference. Okay, so it is that work done to bring a point charge from somewhere, from infinity to that particular point, is called as electric potential difference, right? So unit they are asking, unit is volt, right? And from which device you can measure potential difference? It is voltmeter. From voltmeter we can measure the potential difference, right? So this is the answer for your 10th question. Coming to 11th question, guys. So 11th question is also a very simple problem from light chapter. Okay, so they said an object is kept at a distance of 30 centimeter from a diverging lens. What do you mean by diverging lens? Diverging lens in the sense concave lens, isn't it? So diverging lens is concave lens, converging lens is convex lens. Shouldn't get confused, right? So concave lens. Fine. So the object is kept at a distance of 30 centimeter. So U is equal to minus 30 centimeter. Object distance here is always minus. Sign is very important, guys. There you have to be very careful. And a focal length is also given. So for concave lens, focal length is also minus. So how much? It is minus 15 centimeter, right? At what distance the image is formed from the lens? Find the magnification of image. So image distance, that is V they are asking, and M is also question mark, right? So what is the formula that you will use? Lens formula you have to use it here. That is 1 by V minus 1 by U is equal to 1 by F. So you have to find out V, right? So 1 by V is equal to 1 by F plus 1 by U. So you have to substitute what is 1 by F. 1 by F is minus 15. Plus 1 by U is how much? U is equal to minus 30, right? So you just have to calculate. How do you calculate? Minus 15 into minus 30. So in the numerator you can write minus 30 plus minus 15, right? So you will get your answer minus 45 divided by 450, right? So this is 1 10. So minus 1 by 10. So what is V? V is equal to, it is minus 10 centimeters, isn't it? So image distance you had got, it is minus 10 centimeter. Now you will have to find out magnification. So what is the formula for magnification? Let me do it here. Magnification is equal to V by U, right? So what is V? Just now we calculated, it is minus 10 divided by U is equal to minus 30. minus minus cancel, and that is 1 za 3 za. So 1 by 3, which is equal to 0.33. You will get plus value for magnification. Saying plus indicates that it is a virtual image, right? So this is the value for magnification and this is the value for V. So very simple problem. So that is all about your fourth main. Now let's go for the last main, which carries 2 questions. Each question is of 4 mark. So 2 4s are 8. So let's quickly go to 12th question. Hey guys, here I have written answer for 12th question, that is last main, which has got 4 marks. Okay, so the whole answer I wrote it in a point wise just to help you all. If you want, you can take a screenshot or you can copy down the points in your notebook as it is. So if you can write this much, you will get complete 4 marks. So don't forget to take a screenshot out of it. Okay, so let me explain what I have written and how you have to present the answer for this question. So the question is, explain Faraday's experiment of magnet and coil. State electromagnetic induction with the help of this experiment. Okay, so you have to explain the Faraday's experiment. See, we all know Faraday's experiment is this. This is a coil 1, right? And this is a coil 2. So there are so many copper turns here. So coil 1 has got voltmeter and a plug key. Okay, and coil 2 has got only galvanometer. So that is what I have written here. Connect coil 1 to a battery and a plug key and coil 2 to a galvanometer. So coil 1 will have battery and plug key, whereas coil 2 is connected to galvanometer. Both are set side to side. Actually, this is called primary coil and this is a secondary coil, right? Fine. Insert plug key and observe the deflection in galvanometer. Here I have used some short forms here. G in the sense galvanometer. Okay. So now I'll insert a plug key here. So there changes the current, right? Current changes in this coil the moment I insert a plug key. So as the current changes, magnetic field changes. So this change in a magnetic field induces current in the another conductor, that is in coil 2. That is the concept, right? So insert plug key and observe the deflection in galvanometer. So whenever plug key is inserted, there is a change in current. Change in current changes magnetic field of this coil. Change in magnetic field around this coil to experiences that change in magnetic field, and that leads to the induction of current, right? So producing current, generating current, that's the reason you will observe deflection in the galvanometer, right? Fine. So this shows momentary deflection in one side. Remove plug key, galvanometer shows deflection in opposite direction. If you remove a plug key, again current changes, that changes magnetic field, that change in magnetic field again induces a current. So you see a deflection in the opposite direction. Okay, so this is what the experiment of Faraday. And now what is the conclusion? Once you have written how the experiment is done, you have to write conclusion. So what exactly we can get inference or information from this experiment is what we call conclusion. See, I have neatly written the conclusion here. Whenever electric current, EC in the sense electric current, whenever electric current in coil 1 is changing, the magnetic field also changes. MF in the sense magnetic field. Magnetic field also changes. This causes change in magnetic field of coil 2. Okay, and hence a current is induced in it, where in coil 2 current is induced, which is observed as a deflection in the galvanometer. Okay, so very clearly I have written the conclusion. And now they also asked you write the definition of electromagnetic induction. So I have written the process by which a changing magnetic field, MF is magnetic field, in conductor induces a current in another conductor. So when you have a changing magnetic field in coil 1, you have seen current being generated in coil 2. This is what we call electromagnetic induction. Okay, so hope I'm clear with the answer that is written on a board. So this is how you have to present your answer, and diagram you have to draw it much neatly. I mean, I have done it roughly here, but you have to draw it very neatly. Okay, so this is all about the 12th question that is there, and you have or option also. So you have another question for this or question. So the or question is very simple, guys. State the Fleming's right hand rule. So Fleming's left hand rule and Fleming's right hand rule is very important. So the definitions are very important, guys. So it's a direct question, you can write it. State Fleming's right hand rule. And then see, there is a question: how can we increase the amount of electric current produced in electric generator? So how can we increase the strength of electric current here? By increasing number of turns in a coil, right? So that is one way. And second way is we can also increase the strength of electric current by increasing strength of magnetic field. Okay, so by increasing strength of magnetic field also you can increase the strength of current. So these are the two reasons you can give there. And also write any two differences between electric generator and electric motor. See, electric motor and electric generator differences. In electric motor, electrical energy is changed into mechanical energy, right? Mechanical energy. Whereas in electric generator, mechanical energy is changed into electrical energy, right? And electric motor works on magnetic effect of electric current. Magnetic effect of electric current. So for electric generator, what is the principle? Electromagnetic induction is the principle. So based on this electromagnetic induction, electric generator will work. Based on magnetic effect of electric current, electric motor will work, isn't it? So these are the two basic differences of electric motor and electric generator. Okay, so this is how you can write the answer, right? And now let's go for the last question. See, guys, 13th question is very simple question. This has divided into two questions, A question and B question. A question is, list the uses of convex mirror and concave mirror. Very simple. See, I have listed the uses here. As it is, you can copy and write in your examination. You will get complete marks. Okay, so to help you all, I have already written the answers here in a short form. Okay, so take a screenshot. Uses of convex mirror is, it is used as a side mirrors of vehicles and used in schools, hospitals, parking lots, right? So since it produces virtual images, you know, convex mirror produces virtual images, so they can be used as a rear mirror, right, or side mirrors of vehicles. And coming to concave mirror uses, used in searchlights, torches, dentist mirror, shaving mirrors, you know, all of them are concave mirrors itself. So very simple question. Coming to second question, define principal focus and radius of curvature of convex mirror. So you have to define principal focus of convex mirror. When light rays parallel to principal axis incident on convex mirror, after reflection, they appear to come on the point of principal axis. This point is called principal focus. Okay, so actually this convex mirror is a diverging mirror, isn't it? So when light rays fall parallel to principal axis, usually they meet behind the mirror, isn't it? So they appear to meet behind the mirror at a point, and that point is called as principal focus. Okay, fine. And they also asked you the definition of radius of curvature. So it's very simple. Radius of sphere from which mirror is made is called as radius of curvature, right? So these 13 questions are from physics part, that is part A. And coming to 14th question onwards, it is part B, that is chemistry. So these chemistry questions I'll deal it in my next video. So keep watching. Do subscribe our channel to learn the concepts in a easiest way and in a detailed way. Thank you so much guys. All the best. Keep learning and don't forget to watch my video on chemistry part. Clear? Fine. Thank you so much.